Okay, so we're on to 11, part 4. And so we're going to be talking about the body's response to physical activity. The most evident effects of physical activity in the body will affect the muscular system, your circulatory system, and the skeletal system. There are benefits to all body systems, but these three in particular have the most pronounced effects. Okay, so let's talk about muscles for just a second. There are specialized functions of skeletal muscle fiber types. And so skeletal muscle is going to be the muscle that's attached to your bones, which causes movement, okay? There are other types of muscles in your body. So for example, there is cardiac muscle, which is found in your heart, and there is smooth muscle, which is going to be found around any organs that change shape. Smooth muscle and cardiac muscle are both involuntary. You don't have control over that, where skeletal muscle is voluntary. You have voluntary control over it. So there are three main types of muscle fibers found in skeletal muscle. There's type 1, type 2A, and type 2X. So type 1, they are also called slow twitch oxidative fibers. These fibers contract slowly. They have a high capacity for aerobic metabolism of fats. Okay, they're fueled by aerobic respiration of fat molecules. So these are going to be muscles that are used in low intensity activities. Type 2A are fast twitch oxidative, and so moderate oxidative capacity. These are going to be fueled by glycolysis using glucose either anaerobically or aerobically using glucose or fat. Okay, and then type 2X are called fast twitch glycolytic fibers. These have the least amount of oxidative capacity, so you're not going to have aerobic cellular respiration happening here. Instead, these are going to be fueled by anaerobic respiration using glucose, again, just glycolysis. Okay? Okay, and here's a table kind of summarizing that with a little bit more information. So again, type 1, slow twitch, high levels of aerobic cellular respiration happening. Structurally, they'll have a high density of capillaries. So capillaries are the small blood vessels that are going to be bringing oxygen to these tissues. Oxygen is used in oxidative metabolism, and so it's required. There will also be a high level of mitochondria because you have full oxidation happening, so that requires the mitochondria. And then myoglobin, which again is going to be responsible for storing oxygen. Primary fuel source, again, aerobic respiration of fat. When would these be used? So again, aerobic activity such as endurance exercises, of low to moderate intensity. Type 2A, they're called fast twitch. Moderate oxidative metabolism, so you have some aerobic respiration happening. Again, rich in capillaries, rich in mitochondria. There will be anaerobic metabolism of glucose by glycolysis and aerobic respiration of both fats and glucose. When would these be used? During both aerobic and anaerobic activities, such as mild distance running, swimming, shorter, more moderate activities. And then the last type 2X, these are going to be fast twitch, low oxidative capacity. So you don't have aerobic respiration happening here. Less dense in mitochondria because they're not going to be used too much, and less myoglobin. So you don't need oxygen, high levels of oxygen here. So again, anaerobic glycolysis will be happening inside of these types of fibers. And this is going to be any anaerobic activity like sprinting, where you need short bursts of energy. Okay? Quick movement. The proportion of these three fibers varies from person to person. Largely, your ratio of these three fibers is based on genetics. However, with training you can cause a shift in the amount of these fibers. And again, the proportion of these fibers will shift with aging. So yeah, genetics matters. So we have this phrase, great athletes are born, but genetic potential must be nurtured. So without training, you're not going to keep the proper proportions of these three fibers to aid you in whatever it is that you do. If you're an endurance athlete, you're going to have a different ratio of these fibers than if you are a sprinter. Okay. So what you do is important, not just your genetics. Okay. So training is important, right? Training is going to match muscle strength to your work demands. The more training you do, the more fit you become. Yes, you can change the ratio of these skeletal muscle fibers. Okay. With resistance exercise, you will cause hypertrophy, which is the enlargement of muscles that are being made to work repetitively. Muscle groups that you aren't using, so if you're just not doing resistance training at all, or you're not properly hitting all of your muscle groups, you will experience atrophy. So that's the loss of muscle size and strength due to inactivity. Sorry. Okay. So hypertrophy is enlargement of muscles, and atrophy is the loss of muscle. That's resistance. Okay, so again, training will cause hypertrophy. Not training, being inactive, will cause atrophy. Aerobic exercise is not really going to affect muscles so much, but it will benefit the circulatory system. Here are some of the benefits. So more red blood cells will be produced because you're going to need more oxygen delivered to the cells and tissues of your body, which is done by red blood cells. Your blood volume will increase. There will be an increase in the number of capillaries in muscle tissue. Again, this is all because you have to deliver oxygen and nutrients to those cells. And there will be a strengthening of your heart muscles. Okay. One other thing I wanted to mention with resistance training, not only does it affect your muscles, but it also affects your bones. So bone density increases with weight-bearing exercises. And it could be body weight bearing exercises. It does not necessarily mean that you have to lift dumbbells. Just doing squats, doing push-ups, those are body weight exercises that again will help with bone density. Okay, we're on to 11.5. So in 11.5, we are talking about power foods, dietary advice for athletes in particular. So exercise training and genetic makeup are very important determinants of how athletes perform, but food matters. So wise food choices will allow athletes to maximize their potential. The energy needs of an athlete are going to be different. They will be different for males and females. They will be different depending on the body size of the athlete. And again, energy needs are probably going to be higher for athletes. It depends on the type of physical activity that's being performed. Okay. Here we have some wrestlers. If athletes experience fatigue or weight loss from training, then food and diet, should be considered. You want athletes to maintain weight during competition season, during training. If an athlete needs to lose weight, of course, they should decrease their calorie intake, maybe by about 200 to 500 kilocalories per day, right? Somewhere around a pound a week if you're doing that. And then if an athlete needs to gain weight, again, they should gain weight kind of slowly, increase food intake by 500 to 700 kilocalories per day. Okay. That 500 calorie is kind of the sweet spot for a pound a week. You don't want to gain weight or lose weight too quickly. Okay, so carbohydrate needs. So we know we've seen this number before. The AMDR for carbohydrates is 45 to 65% of the total calories that an individual takes in within a day, but it should match activity needs, right? This is kind of a big range. Individuals who are exercising vigorously for 1 or more hours per day, they need their carbohydrate consumption, needs to be moderate to high. you want to make sure that your fuel training, your fuel needs meet your training. And so you need to make sure that you have proper glycogen stores in both your muscle and your liver cells. For low intensity activities, intake range should be about 3 to 5 grams per kilogram of body weight. Moderate intensity intake should be a little bit higher, 5 to 7 grams per kilogram of body weight. If you are someone who exercises for several hours per day, intake should be even higher, 6 to 10 grams per kilogram of body weight. Okay, so again, that range, it's a big range, and so you want to make sure that it meets your activity level. Depletion of carbohydrates, right, hitting the wall, it ranks just behind the depletion of fluids and electrolytes as major causes of fatigue. And it's not good for the body. So you want to make sure that you have adequate supply of glycogen, of carbohydrates. And so here's just a sample menu. I won't read all of this to you. But this provides, based on MyPlate, okay, some daily menus, again, at different energy needs. So if you are an individual that needs 1,800 calories per day versus 3,000 versus some athletes need 4,000, 5,000, depending on what they're doing. And so again, if we look down here at the bottom, it gives you the different, percentages of carbohydrates, proteins, and fats. Okay. It gives you, again, a sample menu. Okay. Carb loading. We mentioned this in the previous video. I'll make sure I come back to that and make sure you understand what that means. And so, for athletes, you can, when you're exercising, you can deplete your muscle glycogen. Your muscles will then turn to blood glucose, and you might deplete your liver glycogen as well. Okay, so boosting glycogen stores in both your liver and your muscle cells is important. So during endurance exercise that exceeds 90 minutes, muscle glycogen stores will decline, and there may be a gradual decline occurring over repeated days of heavy training. And so you may not have full glycogen stores when you start that 90-minute exercise. And so again, you want to maximize the body's ability to store glycogen, and so you would follow a carb loading regimen. And there are different regimens out there. One of the ones presented by our textbook is, number one, you would taper off training intensity and duration about 6 days prior to a competition. And then you also want to follow a high carbohydrate diet for the 3 days before a competition. And doing those two things will increase your glycogen stores in both your liver and your muscle cells. And that's the goal. The more you have, the less likely you are to hit that wall. Okay. Who should carb load? Anybody who competes in continuous, moderate to high intense aerobic events, lasting more than 60 minutes, or in short events with repeated bouts of exercise, occurring more than once in a 24-hour period. So, marathon runners, even if you run at a slow pace, even if it's not moderate intensity, you still, it's a long time to have to run, to ask your body to provide fuel, to provide ATP. And so you want to make sure you have enough stores on hand. We'll talk about fueling during these kinds of things too. Long distance swimming, cross country skiing, triathlons, soccer, long distance cycling, long distance canoe racing. Again, you want to have stores of glucose. Okay, so that's carbohydrates. Fat needs. So fat needs for athletes should be between 15 and 25%. It's a little bit different from the AMDRs. Fats, of course, should come from unsaturated fats. You want to limit saturated and trans fats. That's the same as non-athletes as well. Studies on the effects of the ketogenic diet and athletic performance have mixed results. There are some athletes that have tried this. Again, mixed results have come. Okay, and then how about protein? So protein needs for athletes are higher than the RDA for adults. So the RDA for adults is shown down here, and we've talked about this in previous chapters, is 0.8 grams per kilogram of body weight. For athletes, it's higher. And so protein needs for athletes, are somewhere between 1.2 and 1.8 kilograms, grams per kilogram of body weight. And that higher protein need is because when you're exercising, tissue actually becomes damaged, and so it needs to be repaired, and also synthesis of new muscle cells. Intake above these numbers is not beneficial. The trend right now is, high protein diets, and if you calculate, your protein need, you should stay at that. Any excess protein, some of it can be used for energy, right? When amino acids are used for energy, first that amino group, the NH3 group, has to come off. We call that deamination. That will then make its way into urine, and so having more protein than is needed does increase urine production. And when the amino group goes into urine, it also takes with it electrolytes, and so that can lead to dehydration. So not good, okay? Also, individuals who consume higher than necessary levels of protein aren't hungry for other foods, and so their carb intake tends to be lower. And insufficient carb intake, again, affects your glycogen stores, which can affect performance. Okay. On top of this, for individuals who, are not active or who really eat above their protein needs, that protein can will turn into fat if it's not used for energy or used for, building tissue. So we got to kind of think about that as well. Okay. Vitamins and minerals. So the requirement for vitamins and minerals for athletes is about the same, maybe slightly higher. Athletes have higher energy intake, and they tend to consume enough vitamins and minerals. The exception here would be athletes that are on low-calorie diets or some type of a restricted diet that are not consuming the right foods to get minerals and vitamins. And so therefore those individuals sometimes are advised to consume foods that are fortified with vitamins and minerals. And sometimes they're advised to take supplements. But usually you can get all of the vitamins and minerals you need just from food. And usually supplements are not required. Okay. And again, that's kind of here. Adequate intake of these nutrients can be met with a healthy diet and really should not require supplementation, although, sometimes that's not true. And so sometimes we do require supplementation. So for example, my daughter is a distance runner, and she does not take in adequate amounts of calcium. She does not like milk. She likes cheese moderately. Yogurt, no. Not a fan of green leafy vegetables. So her calcium intake is not adequate. And so she does take a supplement. Important for her. So again, it's really individual. Depends on what your diet looks like. And she's 15, so can't force her. The requirements for some vitamins and minerals, again, may be altered in athletes. So, for example, B vitamins are used in energy conversion, so athletes might need more of this. Calcium is used for muscle contraction, so athletes might need more of this. And then iron. Iron is going to be used to carry oxygen. It's involved in the production of ATP. And so, again, iron levels for athletes might need to be a little bit higher. Iron deficiency. Iron is involved in red blood cell production, the transport of oxygen via red blood cells, and also energy production. Individuals who are low in iron, so first off, females are most susceptible. Special diets, such as low energy or vegan diets, will be low in iron. And then intense workouts, especially of distance runners, may lead to low iron. Okay, and so those individuals, through blood work may find that their iron levels are low and may have to take a supplement. Iron deficiency, continued, sports anemia versus true anemia. Exercise does cause blood plasma volume to expand during the start of training. that can result in the dilution of blood. And so this is kind of a false reading. Blood iron tests may appear low, but it's not true anemia. True anemia is when red blood cell hemoglobin and hematocrit levels fall. This is seen in about, again, 15% of males, 30% of female athletes. And again, if this does happen, iron supplements would probably be advised. Okay, calcium, back to calcium one more time. So again, low intake of milk and dairy products, which again, I've experienced in my own life, can lead to low intakes of calcium, which compromises bone health. Relative energy deficiency in sports, which is called REDS. So again, low calcium, poor bone growth, stress fractures, early osteoporosis is a danger, low estrogen levels, delayed menstruation, and increased risk of injury. So, not very good. So again, athletes have to make sure, everyone has to make sure that they're getting appropriate calcium intake. And I think we'll save 11.6 for the next video.